Well, I've got quite a bit done since the last video. Kind of three major components have been included now, and that is the IF amplifier, the AGC circuit, and then down the bottom we have the VFO right here. So the IF amplifier, as I mentioned in a previous video, is an MC1350 monolithic IF amplifier. I'll include a data sheet down below for that. To demonstrate that the IF amplifier is actually working, I can use the same crystal tester technique that I used for the SA602. So I've just turned the crystal tester on. You can hear the tone there, and then just to confirm that the IF amplifier is actually receiving the signal, I just tap my screwdriver, accident antenna, to pin 4, which is one of the IF one of the RF inputs pins to the MC1350. Now, the AGC circuit itself, I haven't tested that yet. Basically, it consists of an op amp, which takes as input from the audio section, and that feeds that into a pin on the MC1350, which is specifically dedicated to AGC. So all appears to be working there. So we can move now on to the, I'll just turn this crystal tester off so we don't have that annoying tone. Now we can move down to the VFO itself, and that's in the center of the screen. You can see it there. So the VFO construction, this is a Colpitts style oscillator, and the feedback from the FET just here. So the source for the FET gets fed back in between these two 1200 picofarad capacitors. So these form the Colpitts circuit. The inductor is this T687 toroid with wrapped with 59 turns. Completing the tank circuit, you can see here is another 1200 picofarad capacitor that goes between the inductor and the two Colpitts capacitors. You can see also here there is the usual diode resistor combination at the gate of the FET, which prevents overdriving the FET. And then behind the variable capacitor here, there is another 180 picofarad capacitor. There is a set air gap variable capacitor here that allows you to adjust the upper and lower frequencies of the VFO, and then of course there's the air gap capacitor right here. Now this particular capacitor doesn't have the 5 to 40 picofarads range that the VFO required. It does have a 90 range, however, which is this range right here. In order to make it 5 to 40, I included an 82 picofarad capacitor right here in series with the capacitor. That gives me approximately 5 to 40. It's around about 9 to 44, so it's kind of close enough. For the requirements there. As I mentioned before, the inductor is a T687 with 59 turns. Actually did start out with 60 turns, and the kit specified 58 turns. So I always like starting with a few more turns than is required. You can always take off turns. It's kind of hard to add turns on. So like I said, started with 60, and the VFO was running a little too low, so I took a turn off and that got it pretty close to the specification. So the specification was 2.935 megahertz to 3.085 megahertz, and what I ended up with is 2.935 to 3.068. So I'll just pan over to the oscilloscope so you can see the range. So that's with the capacitor fully open, and then this is with the capacitor fully closed. So you can see what I ended up with is with the capacitor fully closed, it's 2.93514 megahertz, and then with it fully open, it goes up to 3.06873 megahertz. So that's pretty close to the specification. As you can see there, it's very stable as well. That last digit is 10 Hertz, and as you can see, it's quite a stable VFO. So quite happy with where that ended up. Now I did actually have a problem with the initial circuit. It wouldn't oscillate at all. So you know, checking and rechecking, I found that I had, this is another one of these double-sided board challenges. I hadn't soldered this capacitor on the side of the board facing us. So as soon as I'd got that soldered in, it worked fine. Actually, the first thing I tried was replacing the FET. I'd kind of assumed that I'd perhaps blown the FET, but that didn't do anything. So it turned out to be that missing connection. So so where do we go from here? So I think the next step is there is a receiver incremental tuning circuit, and I'll just move the schematic in the way here. So the receiver incremental tuning circuit is this portion here, and it's formed by this LM393 comparator, and I'll explain how that or how I think it works in the next video. So that'll be a bit of fun. I've already got the comparator in place, but none of the associated circuitry is around it. So all is going well so far. Now, like I said, the stage after that involves using this edge connector that I'm pointing to here, together with some band-specific modules that you have to plug in. So I'm still waiting for the edge connector. Like I said in one of the previous videos, I did order that off eBay. So hopefully that'll be arriving in the next week or so. And at that point, I'll be able to feed the VFO through the premix oscillator into the receive mixer, which I haven't got put on the board yet. So that will be to come. That's all for now. Catch you later.